All right. Now I'll anxiously wait for 30 seconds to make sure I'm live while I keep refreshing the stream. I think I can hear myself. Can everyone hear me? Let me make sure I can. I think, yep, I can hear myself. There's the echo. Cool. Welcome back, everyone. It's always this anxious start. I probably need to work on the start of these live streams, right? It's always this very filled live stream. So the first thing we'll do is we'll refresh what this live stream is about, and I'll bring you up to speed. And even before that, let me get this disgusting mouse charger out of the way. I have a wireless mouse, but I never have it charged, so it's always a wired mouse. It's absolutely weird. If you're joining me for part two, and if you've watched part one of this live stream, thanks for watching part one and joining the part two. The plan was to cover or pick up where we left in the last live stream. So every week we go through top Kaggle solutions to learn different things. And last week we had learned some top tricks from BirdClef 2022. At that time, I wanted to cover both 22 and 21. So these are the competitions from last year and the year before. Every year there's a competition with the same name, and the task is pretty much the same. So you have to classify audio files from. You have to classify bird classes based on the audio files. No puns intended. I was thinking if that's a pun. We had looked at how to get started in the competition that's going on right now. So it's called no no surprise BirdClef 2023. And last week we had also taken a look at a baseline that can get you pretty high on the leaderboard. This is the one I'm talking about. So today's live stream and the live stream before this is both connected to this. That's why I thought I'll do a part two. Some of you were asking to do another follow up part and cover more solutions. So this is for you. I'll do a warning. Usually the live streams are about an hour, and I'm grateful that everyone joins them for an hour or so, or sometimes even longer. This might be shorter because we've already covered the meat of it. Although if you haven't watched it, I'll still give a quick refresher about different things. So let's jump into it. And I see people in the chat. Let me know if you've watched the previous live stream and if I'm repeating a lot of things. So I'll skip past that. So I'll do a refresher on working with audio based files, and I'll head back to my favorite deep learning framework or deep learning tool, Hydrogen Torch. And this was made, I've mentioned it quite a few times, but this was made by top ranked Kagglers from H2, which is why I think this is always a good start for me to understand, or a baseline for me to understand how to approach different things. So what I'll do here is I'll show you a demo of a simple audio data set where you can see there are different sounds of dogs, roosters, sneezing, sea waves, raining, a crying baby, helicopter, quite a few files. This is a standard data set. And if I look at the visualization or the stats, I can play these files back. I don't think my live streaming will allow you to hear that, so I'll go past it. But you can see there are about 400 labels and I think 400 examples also in this case. Yes. So what I want to do is create an experiment on this, and Hydrogen Torch is a no-code deep learning tool, so that means that I don't have to do anything. I just need to select options from all of these menus, and it always does come up with the best model by navigating through the defaults. And many times there are many ideas baked into the product as well that take care of a lot of things that make your life easy. So I'll just train one fold for now. It's already identified the label column, so we'll sample the entire data set, and now we'll get into the different settings you are working with when working with audio files. So you can see you can either leave the audio parameters to auto or manual. These calculate parameters from the training set or allow manual override. So when you're working with these files, you could, and we've seen in the previous live stream, many of the top solutions had these manual parameters that they were tuning or working with. So I think this is analogous to that. Now, if you have the domain knowledge, you can override it and change that. I trust Hydrogen Torch to do a better job, so I'll leave it like that. This is pretty cool. So you can also have mix up with audio, and you can tweak the parameters a little here. I'll use a pre-trained model, which always is a good idea. I'm curious, when is this not a good idea? Because there's obviously an option there. So, to the best of my knowledge, it's always a good idea to leave this on. We can select a backbone from here. So, what is going on here is when you're feeding an audio data set to hydrogen torch or your models, it ideally gets converted into a spectrogram, which is an image of graphs of the audio file inside it. There are models that can directly work with audio files, so you can feed the audio directly to the model. But since CNNs are so far more developed, that's my understanding that usually converting to spectrograms and then feeding that to a CNN model is a better idea. So I will select the backbone here, which I think Resonate 34 is a good one for our case. I leave the dropout off. Change this to gem pooling. And from here, you can see it's pretty much similar to building any model. So you can change your scheduler, similar settings to anything else. I leave the metric to be the default. And just like that, I can kick off the training. So the main thing that is differentiating here is you're taking the audio dataset and converting that into spectrograms and working with that. So this is how you do it in Hydrogen Torch, and usually you have different backbones that you want to experiment with. Last week, and the live stream is linked under the like button. You can watch it if you want. We had learned about a architecture called SED, which someone from a previous competition had come up with, and that was pretty popular. So just another refresher. I'll spend 5 more minutes quickly highlighting what we had learned already. In the 2022 competition, you had to identify bird calls, and you had the following columns to work with. So you had the bird species. You were also given secondary labels. There were ratings. So these sound files were gathered from a website where you could leave a rating, and these are given rating from 1 to 5, right? And the audio files were structured like so. So you had varying numbers of different species inside these folders, and you had a bunch of files in OGG format inside all of them. And our goal was to classify between all of these. Now the trick was you had to identify or give predictions on 5-second windows, whereas these could be in varying length, and you didn't know where the sound of the bird was occurring in the training data set. So that was part of the challenge. So last week we had looked up until 5th place. So I'll pick off on the 6th place competition. Sorry, 6th place solution. Let's continue from there. And this is by Shin Marau. I hope I'm not messing that up. So they had used, they say, only using SED model. So it looks like, is it a single model solution? I think so. Many clean data with human in the loop for weak label. What does this mean? Human in the loop, this was a very efficient method which I share with you. Let's take a look. Annotate 1400 images in 4 hours, train that, run inference, and you manually verify those images with a yes or no. Oh, cool. So they had actually manually babysitted the model for bad labels, looks like. Heavy post processing, which got them the major boost. So looks like the meat of their solution lies in the post processing. And they say clean data and post processing is important part of my solution. So looks like this babysitting and the heavy post processing is the crux of it. So they had made annotations in 2021. This is effective, but hand labeling is time consuming. So for that reason, they used human in the loop method, basically having the model do some predictions and manually verifying that. For training, they had used 3 types of data sets. The first one that they had themselves created, other data, not scored bird data, about 130 species, and pseudo data. So they had also pseudo labeled, it looks like. And it was a mix of pseudo labels here. So They had come up with a strategy to mix up, pun intended, their data set. Is this readable for you all, or should I zoom in a bit more? I think this is fine, right? I'll continue, and if it's not fine, let me know. So they had used two backbones here, NFNet and NFNet L0 and F0, only using clipwise output. They had done a basic augment of time shifting, adding noises, and mixing some other data sets. We've already gone through all of these spec augmentation and other augmentation techniques. That's why I'm speeding past them. They'd also done label smoothing. All of these look like pretty standard, similar to what we have uh, read in the previous solutions, and it's pretty cool to see. I'm guessing that this gold medaling solution comes from just Colab. So that is another epic achievement, right? Like they're first of all, it's I think a single model, and that too has been trained just on Colab. So pretty epic, if I may. Okay, I am. I need to correct myself. Looks like they'd used 10 models, but still, I assume it was trained on Google Colab. So that's pretty cool. Post processing is similar with the 12th place solution. Let's go and read that first. Okay, this becomes a loop, right? Because it points us to another discussion, which points us to another discussion. That's pretty epic. Let's see how far we can go. Part of 18 place solution model, train segment shift. Where is the post processing? We average the prediction for a given 5-second chunk with predictions for chunks shifted by 2.5 seconds forward. Prediction for a 5 second with prediction for chunks shifted forward and backward. Oh, so this makes sense. So they had done this sort of test time augmentation, if I may. It's not really test time augmentation, but I don't know what to label it. So they were making sure the model was predicting on this like sliding window, looks like. This post processing is especially effective to deal with cases when a bird call is located at a boundary. So that's why the sliding window as a call it makes sense here. That's really cool to see. This is such a cool trick. Thanks, IFOs. Going back to the discussion we were at, this is the prediction time shift that they had applied, and it looks like a similar formula. Test time augmentation, let t be the target time. I use three type inputs, t and t plus 5 window, t minus 1, t plus. Okay, so they were running the inference on these three different windows, trying to get bird call on the edges. So the main challenge was you had these 5 seconds where you were supposed to make the predictions. And as people have mentioned earlier, sometimes the bird sound would just be at the edge of it. So let's say if I'm starting to talk, I turned off my mic. But if I'm just starting to talk and if I move away, right, or if the audio stops there, it's hard for you to understand. And the same applies for any model. So I assume just like having that 1 second slide over is pretty helpful. Now am I worried if I turned off my mic? But I assume that's that's where it was helpful. Threshold optimization. I tuned the threshold like this being lower threshold has good score. Okay, so we had gone through this in the last live stream. Thresholding of sigmoid function and having a lower threshold was helpful. That's the gist of it. If a model detects a bird once, I lower the threshold and infer it once more. Different things that didn't work. Nothing stands out here, so we can move fast. One cool thing, ArcFace has a few shot learning method didn't work for them. And we had just tried, I think, in one of the previous solutions, it was quite effective. So this was the sixth place solution, and we can continue further. So now we are at closing the irrelevant tabs. Once we get there, now we are at the seventh place solution. Summary of their solution is they had used a constant Q transform. This is again one of those techniques that, if you're working with signal processing, so it's just a transformation applied to the audio file. It's like image cropping. It's as similar to image cropping as that. um, so constant Q transform, multi-step training with PyTorch Lightning, pre-training on data with noise from rainforest, fine tuning with weighted sampling. So they had pre-tuned on both of these data sets combined with noises, and then just fine tuned on this data set. Sequence based modeling, and then they share the score. Okay, so looks like this was a bit of the crux. This fancy way of first pre-training their model and then fine tuning, and then how they decided to mix this noise here. In this competition, there were main two challenges: domain mismatch with very noisy test data, long class distribution with a few examples of real classes. I use traditional pseudo labeling two-step training, and they've defined that right here. They've described Q transformation. This is a function that's pretty common. So I have read enough audio solutions to see this occur a few times, but it's just a simple call from nn audio.spectrogram library from PyTorch. So everyone knows famously I'm a PyTorch person. This is from PyTorch. I'm sure there's a function in TensorFlow, or I don't know if someone's using JAX, possibly in JAX. Let's take a look at their model. I use semi-supervised pre-trained ResNet, MIT B2 transformer, and seg-former backbone. The last convolutional layer is followed by the last conv layer is followed by a convolution, collapsing the feature map into a sequence of vectors with a transformer layer and a head producing sequence and clip outputs. And here they have provided the code of how they've changed the existing models. And they say this is somewhat similar to ACD model. So this is inspired by that architecture. Initially, they believed MIT transformer with a large receptive field is important, but it appeared to not really be true, and their favorite ResNext 50 performed nearly the same as MIT B2. Now they describe the training step again, which I'll skip past this time. For inference, the inference is performed on the entire audio files, while training is done on 5-second clips, followed by fine tuning on 10-15 seconds. That makes sense. The test audio clip is split into 5-second chunks, and the predictions are selected if the maximum output reaches the selected threshold. For post processing, the model output used was following. Pay attention to the dimension, which is the class rather than the sequence dimension. That makes sense. So they're using the class here. And they had also used temperature rescaling, which I don't know what that is. Bhavya is saying hello. Hey, Bhavya. I need to kick Ayushman permanently, or I need to ban that word at least. Ayushman just joins the live streams to troll me, I feel like. Um, so in this competition, the main focus is bird classification, and no credit is given for call or no call separation. In contrast to the older competition, so the best scores can be achieved at selections of very low thresholds. So that's the reason for low thresholds giving the boost. because you're just doing classification here and not doing an identification. If you use more reasonable thresholds, the performance drops a little. So they couldn't work with, they couldn't make ArcFace work and couldn't make metric learning and clustering work for their case. And it feels like this is, they say they wanted to be on the top of the leaderboard. For me, this is already on the top of the leaderboard. But that's the difference between me and top competitors. So they could have done better, is what they're saying. Cool. That was the seventh place solution. Moving on to eighth place. They started with the public notebook at this link. So I've not seen this. Let's take a quick look. Install Librosa, install colored noise. I don't know what that is. Let's take a look. Colored noise. Generate Gaussian distributed noise with power law spectrum. So basically a function to add noise to your audio files. Looks like that's what it is. And it has a somewhat simple API, right? Looks like it. Cool. Manually putting in the target columns. Okay, looks like they're converting it into a mail spectrogram and performing some normalization, performing some noise ejection, adding some Gaussian noise, adding some pink noise, adding some time stress transformation, adding some volume transformation, uh, computing the Mel spectrogram. So it's somewhat similar to all other baselines using a Mel spectrogram and performing inference on that. That's what this looks like. With changing Mel spectrogram, hop length, and input shape, adding class weights, weights arrays 500 divided to amount of birds species and clamping it. So they had given a different weightage to classes, it looks like, and then multiplying the model outputs with this weightage, and adding secondary labels and doing an ensemble got them to the gold medal. Sounds pretty simple, doesn't it? But I'm sure it took a bit of figuring out. I'm just thinking if there's something secretive missing here. It doesn't look like it. For waveform, they share how they had computed it, and we've already sort of gone through this. For spectrogram, they're using torch audio transformations. What didn't work? Noise reduction, oversampling rare birds. I would have assumed this would have helped, but looks like it didn't. Trim long silence with noise reduction didn't help. This is pretty mind opening, right? Like, because I would assume these are pretty basic tricks that at least I would use. Manually trimming all segments without bird sounds from scored audio. Uh, okay, so this is the second step. I thought this was another thing that didn't work. So this was part of the first step where they had come up with this model. The second step was trimming all segments without the sounds, splitting them into 15-second chunks, using weighted arrays, and training on this data with previous pipeline and ensembling the previous model. Then there was a third step. Use similar with AST processing. So I assume it was similar to the previous two steps. Every epoch from all data randomly choose up to 300 records for every class. So during every epoch, they are randomly sampling 300 examples. But what about the classes that don't have that number of examples? I'm curious about this. This isn't very clear to me. Let's see if it's clarified below. Nope, it's not. So this will remain a mystery. I don't know if anyone in the chat knows of this. So they're saying every epoch from they are sampling 300 records. But what about the classes that didn't have 300 examples? I don't know. um, they had given a zero point 0.4 weightage to secondary labels, applied a clamping with a max value 8, applied mix up. Finally, some post processing, mean, median, averaging of predictions got them to the final gold. And here's the story of the gold medal. 2 days. It's always on the last minute, right? Like all this is common to all gold solution. Always on the last day of the competition. And there's some wisdom in it, which is don't give up until the competition ends. I thought about pseudo labeling and separating data by zero point 0.8 threshold to remove all noisy records. Then trained a new model because there was not enough time. I trained model on all data. The first three submissions were lost because he forgot to use model.eval. Fourth attempt, a single model got 0.79. And the last one was mean between. So it looks like just the last solution on the last day got them to the goal. And you can see I'm smiling because I can only relate, right? Like how much of a fun last minute push that would have been. And this is common to many top Kagglers. So looks like they had done a three-stage approach. I was trying to think of is there like any special thing that hops out here, but looks like it's an iterative approach over the same ideas with some changes. And that's cool to see that even starting with a very simple, very vanilla notebook and iterating upon that can actually get you to eighth place, which I think was a solo gold in this one. Yep, you can get a solo gold with obviously a lot of efforts. 235 submissions. That's slightly less than this, but quite a lot, right? Pretty cool to see. Awesome. We'll keep going. We'll go on to the ninth place summary. Let me check the chart. Nothing. No one is talking about coffee, so I'm happy now. And NVNN is a bit of a legend in computer vision, so I expect they would have done some fancy computer vision tricks here. That's what I'm expecting. I skimmed a bit through this, and I don't recall which solution is which, so I'll have to see now. Their solution is an ensemble of one SED model and one Mel spectrogram classification model, which got them 2.79. They give the details of SED model, and nothing important here, so I'm skimming past it. Mel spectrogram, they had used a ResNet 50 here, trained on 7 seconds of random crops. The augmentation was noise injection, changing the pitch, changing the volume. They had done 2 rounds of training, so I assume this might have been pre-training. We trained several models in ensemble to create an out of fold. We combine ground truth and out of fold to modify the target, and then train on the modified target. Oh, that's pretty cool. So they had done this sort of two-stage modeling. It looks like if out of fold is greater than zero point 0.5 or target is changed to 1. If it's more than 0.1, target becomes this. If it's more than 0.01, it's 0.5 changed to 0.5. Okay, so they are augmenting the labels a little, as you can see here, for both the primary label and the secondary label. We found the public LB is very sensitive to thresholding. The optimal threshold are very different. So weight averaging does not bring much improvement. They ended up multiplying their probability and set the top 33% highest confidence score. As true, the rest was false. Okay, so this is these two rounds of training looks like the trick. Their model looks to be similar to all other competitors. And if I were to like point one thing that stands out, it looks like this would be it. Another great read by NVNN. So thank you, NVNN. I had interviewed Jill a while ago about this 11th place solution and also the story behind their team name, which is Kakapu. So I will point you all to that interview. If you head over to the channel, you might have to scroll a bit and you'll find it somewhere. There it is. So it was the 11th place gold place solution with Jill. If you are interested, was that. But since I've already covered it, I don't want to recover it. I'm sure at least one of you has watched that interview already. So we'll move on to the 14th place solution. I started with macro FP score, which seems suitable for the case of noisy labels. I choose quite big beta. So I assume beta is a parameter inside the FP scoring to boost recall. They are trained on two recent recordings from Hawaii, which can be found on Xenocarto. And the input for their case was pre-computed male spectrograms. These were generated with Librosa using default parameters. For male spectrogram, denoising strategy was used to reduce stationary noise. On inference, same approach was applied to the 5-second chunks. They had also performed a log scale and normalization, and they had applied a tiny augmentation and a bit of normalization after that. The approach was the following: multi-class classifier for all species and multi-label classifier for chosen species. In addition to scored labels, the species which have high overlap or which have big amount of recordings, records for unchosen species are used for random mixing with initial output. So looks like that figured out a way to also do this post processing or second level of classification for labels or for classes that had lesser number of labels. Seems like augmentations, random cropping of 5-second window inside the whole file. Time stretching, we've already seen this. Random low pass filtering, mixing no bird records from the external dataset we had seen. Thresholds, trained models were evaluated over whole files from validation set, and best thresholds were estimated. Obtained threshold for different approaches were averaged and tuned by knowledge about amount of data per bird in dataset. Okay, so it's basically a dynamic change in the threshold. If I were to simplify it, post processing for reducing false positives, the following checks were implemented: standard behavior, standard deviation behavior for Mel spectrogram, mean max relations, and checking scored labels over the max prediction over file. Looks like very simple post processing. So this, of course, isn't the meat of it. For this case, it looks like the meat was a bit of the training strategy and this these two external data sets that they are mentioning here. Let's try to cover the 15th place solution before we move on to the 2021 competition, which I have opened in another tab. So when I started, I assumed this would have been shorter than an hour, but looks like we're edging close to that territory. So we'll see. We'll see what happens. Yeah, Aditya, thanks. Thanks for joining. They share the details about their pre-processing parameter, and no, I don't mean to look at the upvoters. I meant to upvote. Um, they're sharing their model architecture, which is a very simple CNN architecture. Yeah, that's there. So we had looked at the seventh place solution, I think, right, which had a fancy change. They had also changed the sigmoid with the length of the classes. They had added a transformer layer and attention layer. But here it looks like it's, if you read through this, it's just a very simple CNN model, which is pretty cool to see. And just by using NFNet, Connext, and ResNet, they got to the 15th place. So pretty epic result if you ask me. Pre-training was done without scored birds. Next, they fine-tuned on the scored bird dataset. We ensemble single train models with the following settings and apply test time augmentation. Post-processing, models with high leaderboard are weighted larger and lower weight lower are weighed lower. Finally, they applied voting method, and to decide the threshold, they had applied the percentile approach from an older competition, from the older one. So this is a very simple approach, right? If you think about it compared to the other top solutions, it's cool to see that even with such simple approaches, you can get very high on the leaderboard. So I know this is just outside of the gold, if I remember correctly, but pretty epic to see for me at least. Yeah, just a few positions outside gold. Cool. Let's move on to 2021. I had discussed a bit about what you're supposed to classify in this competition and what you're supposed to do. So here you have to identify bird calls in soundscape recordings as well. And the data set was pretty similar in this case as well. You had bird details with the ratings, uh, the audio files. You were given a short audio file and a longer version as well. So this is a EDA kernel by one of the hosts, and we'll quickly read through this to just recall everything. The training data consists focal recordings. These were made using semi-professional equipment and usually focus on one species. There's some metadata as well, so you can see the latitude, longitude, common name of the bird, and the date. You have a primary label telling the name of the species. And here's the distribution of number of training samples per species. So you can see there's a fair amount of imbalance. And as we move towards the lower half, you can see it's quite pronounced. So this class has just 8 examples, CRF par. So there's a bit of data imbalance, as you can see. They say you can see the long tail classification problem with highly imbalanced data set. The metadata for each recording lists the number of audible background species, and these are secondary labels. So you have the secondary labels here as well. And of course, some people chose to use it, some did not. You're given the location, and here's a plot of all the recordings where they're coming from. Distribution of ratings. So some have zero rating, which surprisingly is the largest compared to the other lower numbers. And most of the ratings are quite high, it looks like. So we can assume these might be pretty well rated or pretty high quality, if I may. So this was an idea of the data set, and this is what we're working with. And let's take a look at the leaderboard and continue from there. So the first place was by this team, who are from Japan, I believe. Yeah, the thing about my fellow Kagglers from Japan is you always recognize their Kaggle icons, but I sometimes struggle to pronounce their names. So, for example, I know a few. I know Karipuran, I know KVNN. I don't think they're from Japan. I think they're from somewhere close. But in your head, you create this cluster and you just recognize people through icons, right? So that's. But I know people from Kagglers from Japan usually end up ranking really high on the leaderboard most of the times. So in this case, you can see that shaken up by 16 positions as well. Here are my colleagues from H2O, so Philip and ILU from H2O. By the way, if you haven't seen ILU before, I had interviewed him, and you can find his face on the H2O AI channel. So you don't for all of you who recognize him as this graph icon, you can also watch that interview if you're curious about who he really is and if he's a person. I think he's just moved up to fourth place recently. If you want, you can find that interview on H2O's channel. Let's see who else. I think this is Tawara ranked fourth. One more of my colleague Marcos, known as Nanashi on Kaggle, finished 10th. And CPMP was 11th. I think I might have interviewed CPMP about this one. I think it was right around that time. Cool. So the best score was 0.69. Nice. And 0.67 is where the goal sort of ended. So 0.67 is the lowest, 0.69 is the highest. With that knowledge, let's jump into the top solutions. We didn't expect to get to top spot, so we weren't prepared to share our solution. Here's a brief explanation. There are three stages. We use this data set to classify whether it's a no call or not from male spectrogram. We use short audio to predict which bird is singing. We extracted 5 candidates from the second stage, and together with this information, we trained a LGBM, light GBM, to predict whether the bird would be included. So this looks like a second stage modeling. It's third stage in their approach, but it's a second stage model. The threshold was determined by ternary search, and since the threshold varies depending on percentage of no call, we use both the case where percentage is not changed and the case where percentage is reduced. All of them had used Colab Pro as their main machine. Wow. And they finished first, right? Someone had asked, and I wanted to point this discussion out. Anything special that they had used with Colab Pro? And they say Colab Pro is a sufficient computational resource, according to them. That was the answer. So, simply put, three-stage modeling. By the way, to the best of my knowledge, this is the first time an academic torrents link has been mentioned in a Kaggle competition. And this is a legit website, so many people share datasets through it. I think this is another dataset for audio files, as you can see. I don't know a lot of the details. I looked at it briefly, but I know a lot of the academics share datasets on this website. So three-stage approach, use this external data, built a second stage model after training on the shorter audio file, and did a very brief amount of thresholding. as post processing. That got them to first place. Let's read the second place solution. By the way, Philip in this write up says he was just the lucky one who won the dice roll. And if you go to Dieter's comment, this basically, if you translate it, I put it in translate, you can try it yourself. He said he doesn't have luck with the dice roll. But all of them are always smart enough. I don't think it's luck. They're really smart enough to rank high on the leaderboard. So let's learn from their solution. It's an ensemble of several CNNs which take a Mel spectrogram of a 30-second wave crop that use mix up and added background noise to improve generalization. For inference, they predicted 5-second snippets and refined the result by a binary bird or no bird. I'm just reading through validation and seeing what I want to highlight. Their final validation on the full soundscape was close to 0.84. They figured this had mostly to do with the presence of three full songs in validation that do not contain any calls at all. So to make their validation robust, they removed the three songs without calls. For let's say 10 times sample 80% of remaining songs, applies any kind of threshold selection technique, sample 65% of remaining songs, and calculate the score on these J samples. That's quite a crazy strategy, right? Like I have not seen that in a while. Interesting. Code pipelines and data setup. They had used GitHub for code storage, Neptune.ai for logging and sharing experiments. I haven't seen Neptune in a while. Let's see what's changed there. I think at least to me, their platform's UI looks a bit cool now. More refined, if I may. I looked at this a while ago during when I was working on a bunch of MLOps stuff. Cool. So they had used Neptune.ai for logging their experiments to reduce CPU bottleneck. We could have pre-processed mail spectrograms, but in order to be flexible, they computed this on the GPU. How do you come up with such strategies for generating a validation data set? Ask these guys. These three people are on the top of Kaggle leaderboard. Two of them have been number one. One is currently number one. One is rank four. I can only dream of such ranks and only talk to such people at work, which I'm very fortunate to. But I don't know. I thought about it before the live stream as well. Like, how did they come up with this, right? Like, this is one of those things when you read it, it makes sense. But like, if I was given this problem, I wouldn't have come up with it at all. At all. Yep, I'm just awestruck for a second here, just like trying to also trying to think or come up with the answer. I don't have one for you, Bharat. We trained a binary classifier to predict bird or no bird, and they had used SE Resnext or Efficient B0 for this. Bird classifier, let's take a look at this. They speed the Mel spectrogram, Mel transform. So they perform a Mel transform on the audio files, perform mix up, feed this to a backbone. From there, they are performing some form of post processing with changing the time segments, applying a pooling layer followed by a linear layer. After the backbone, they reshaped the data to rearrange to 30 seconds by concatenating the respective time segments And then use simple pooling of time and frequency dimension before forwarding through a one layer head. We naively use the union of primary and secondary label as a target. I'll skip past this. We've already sort of seen the highlight here. Ensembling was straightforward. They took a simple mean. Post processing, the first step was choosing an appropriate threshold. We quickly realized the test and regular validation had different proportions of calls and no calls. This meant you wanted to predict more birds on LB, lowering the threshold. Second, choosing hard thresholds can be problematic. Each new model has certain shifts in probabilities, so global thresholds can shift quite a bit. In the end, they decided to move to a percentile based thresholding approach. I'm again thinking, how did they come up with this? I don't have an answer. A relevant question here, this about this transform. Well, transform of audio is treated similar to pixels in images. This is really common in audio processing. And I think you just joined Bharat, so I mentioned it earlier, but from what I understand, the reason is because there are some transformer models where you can feed the audio data set directly. But since CNNs are much more developed, converting to spectrograms and working from there is usually a better approach. That's my understanding of it. In theory, the gamble was legit because private LB even had more birds. But at the same time, it seems that the ranking of predictions was worse. They believe that this percentile based approach was way more stable and robust than individual thresholding. They had applied some other post processing steps like increasing the probability of birds based on their average prediction probability, smoothing neighboring predictions, and adjusting predictions by predictions from individual models. They had explored pseudo tagging, which did not work. TTA with male spectrograms, they say, isn't very straightforward. So really cool to see. First of all, very very inspiring validation approach. I haven't seen something like this anytime earlier. And even the percentile based thresholding, right? It's really cool to see. So I haven't seen that in a while as well. Sorry, I haven't seen that anywhere else as well, at least in this competition. Um, yeah, that's about it. That's what I wanted to highlight from this one. So cool to see. This was the second place solution. Again, to quickly re-summarize, the thing that stood out was the validation approach and the percentile based thresholding instead of a dynamic thresholding. And no, I don't want reader mode. Let's move on to the third place solution. The final solution was an ensemble of 18 checkpoints trained on different CNNs and folds. During training, each model are trained on clip of 20 seconds. Post processing is applied during inference based on prediction at the clip level and segment level. The first observation they made was training, they have a weak label, so we can use supervised learning to minimize loss function. For testing, we have to predict every 5 seconds. Therefore, there is a gap between label and inference. No problem, Bharat. Um, why training on a clip of 20 seconds and not 5 seconds? The hypothesis was training on a small clip will introduce noise uh, to our training. Bharat says he's still processing what the validation and percentile thresholding are even doing. Um, I can go back and explain that after just reading through the solution. So I don't want to like switch context too many times, but let's read the third place solution. The hypothesis is training on small clip will introduce noise to the training. We don't know where and which bird is singing. So the training files were 30 seconds, and somewhere in there you had a 5-second noise of the bird. So they are saying since you don't know where that would happen, it is possible to add noise through this. Their model was based on the SED model, which we've now looked at a few times. And they had employed SE Resonate, B2, and B3 efficient models from TIM. And this was 2 years ago, right? So that's why you see it's this library, and it's everyone is not going, oh, this is from TIM. This is not from the best image framework, which now it is. And attention blocks in order to compute the final output is added. The attention block is applied on the first output of the backbone. During training, we are trying to minimize the output of attention blocks with cross entropy loss. We are trying to predict in 20-second clips, and they're using label smoothing to help with the noisiness in the label. So randomly crop 20 seconds, create spectrogram every 5 seconds, feed that to a SED based model, uh, have an attention block, and calculate the output from there. Take the output of the attention block to get the final probability at clip level. Post processing using the attention block output and time segments output. Post processing inference, they had created two ensemblings. Have you all seen this word before? Ensemblings. This is the first time I saw this word. One based on the final output, and second one based on the max of the prediction of timestamp segments. To decide if the bird appeared, I need to look first if the bird appeared in the ensemble prediction of the max timestamp segments, and if the bird also appeared in the final prediction. So they had done a two-stage thresholding for predicting if the bird appeared or not. And this was 2 years ago, which I think 3090s had come out around that time. I'm just seeing. I know like what they're referring to by ensemblings, but it's just cool to see. I don't know if this is like a common word. It's like siblings of ensembles, right? That's why I laughed at it. This was 2 years ago, so I think 3090s had come out, but they had still finished really high with the 1080 Ti. So this was the third place solution. Let me answer Bharat's question. So they are still. Bharat said he's still trying to figure out what's going on here. So simplifying a bit extra, whenever you're validating, you're trying to come up with a way to represent the test data, right? And you're trying to score on that. This competition was quite shaky in that sense. So very simply, they had like removed 3 songs in the training that were causing an issue because they didn't have any boards in it. Then they sampled 80% of the data where they're emulating the public plus private mix. After that, they sampled again 65% of the remaining songs to emulate the private test set. And this is where they calculated the score. So on the first sample, they applied the thresholding selection, and on this they are applying on this they are calculating the final scores. Now, for thresholding, many people had just like looked at the probabilities it looks like and changed them directly. So let's say if your like probabilities are, or if your probability is above zero point 0.1, you would just like set the threshold lower and put that as a class in there. To account for what I understand, the data distribution, they had flattened all predictions and then calculated the threshold, which looked like this. The more birds a set contains, the lower percentile can be if predictions are decently ranked. And this gave them a stable percentile approach. Stable predictions approach. I don't know if that made more sense. Let me know if it did not. I can try one more time. And I had promised to keep this under an hour, but looks like we might go over it. So I'll probably wrap up here, because I think all of the remaining solutions would take some time. I was only able to cover the top three, and I hope that was helpful enough. We have BirdClef 2023 going on, so I don't know if you'll find this useful. I hope you do. And let me know if you end up using some techniques there. You can watch the previous live stream for a baseline on how to get started. But this is a BirdClef 2023. It's going on for 2 more months at this time. Cool. One more announcement. I've been playing a lot with generative AI models, specifically image ones, now a bit more with ChatGPT. You can expect a study group starting around that pretty soon. I've already started making short videos, which I'm very new to. I've linked both of them under the like button. If you have the time and if you have the interest, please watch them. Let me know how you like them. I'm trying to like also experiment with shorter videos instead of 90-minute live streams. Let me know if you like that. Otherwise, if you're just here for the Kaggle stuff, we'll keep meeting Sundays and keep learning. So thanks for joining, and I'll see you in the next one.